Okay, let's talk about the challenge problem of the chapter 4. So the first problem is the area of the trapezoid. So for trapezoid, I want to introduce the trapezoid is a cutting through the parallelogram. Okay, so like we cutting here, and this one will be equal S and S, they are equal. Okay, and for this one is pretty special because the right angle, right? So it's a cutting through a rectangle. So we cut it. So that's why we have the A, B, C, D here, right? This is another A, B, C, D. So it's 5 and 6 and 8 and 8. So you can see it's 13 times 6 divided by 2. Then it's 39. Okay, the second question. So the second question is a garden that's enclosed a square. So we have a square, right? So each have the same length. And this garden has a perimeter of the 96 feet. P equal 96 feet. Then we want to put the post at 6 feet apart. Okay, and plot at the corners. So we have everything at the corners, and how 90 we want to put 6 feet apart, right? So how many? So there are two ways to solve it. Method one, if let's think we can put some post here, right? Put some post here, right? Put some post here. Put some post here. Okay, so let's group as this, as this, as this, and as this. So these four groups has the same length, right? And you can see that these four groups are equal length, and they cover how many the length? They cover the 96 minus, we didn't count this one and this one. Yeah, we didn't count this one and this one, right? We need to subtract 4 times 6 divided by 6 is equal to 12. Okay, this is method 1. The method 2, it's very similar. So you use the 96 divided by 6, and it is 16, right? But you can see all the posts on the corner getting counting on this side, double counting, right? So that's why we need to take out 4, also equals 12. Okay, so this one is related with the called the fractional geometry. 中文叫做分形几何 Okay, that means through a repeat pattern, you can see the perimeter becomes very more bigger and bigger. You will see, like our DNA. Right, we have a limited spacing, but we want to put a very, very long string. Okay, so now let's do some pattern analysis here. We have 1, and we have the side length, and we have the number of side, 1, 2, 3, and so on. Okay, so the first, let's assume the side length is A, and we have 3 sides. Now the second one, right? So this is the one side. This is the original. This is the one side, right? Now this side getting into cutting 3 equal pieces. So each side length becomes A over 3. And the number of side lengths on this one is 1, 2, 3, 4, right? So basically it's 4, and we have also 3 sides, this one and this one, so 4 times 3. And now let's see the 3, okay? So the side length of A over 3 is further cutting into 3, right? So it's A over 3 square. And how many sides? So you can see each one each one getting into become the 4. 1, 2, 3, 4, right? So that's become 4 times 4 times 3. Okay, so now if we can see, we can figure out the pattern, right? So this one equals the 4 squared 3. This is 4, 1, 3. Did you see it? So for the n, it must be the a over 3, the n minus 1, right? And this is the 4 to the n minus 1 times 3. Okay, so what is the perimeter now? Perimeter of the n is equal to a 3 to the n minus 1, then times 4 to the n minus 1 times 3 is equal to a times 4n minus 1 and 3 to the n minus 2 for n greater equal than 2. Okay, so this is how we can get it. Now, I mean, if you want to see what is the question ask you, if the perimeter of the first figure is 12, right? So first figure is 12 means a equal 12 over 3 is 4, means a equal 4. What is the perimeter of the third figure? So the P3 is equal to the 3 to the 1, and 4 times the 4 to the 2 is 64 over 3. Okay, so next question. Next question is, what's the process of this forever, right? We already derive it. So Pn is equal to the Pn is equal to the 4n. Yeah, if Pn is equal to the 4n over 3n minus 2. So you can see if n reach very, very big, right? And the Pn will reach infinity. Okay, so this is how the fractional geometry works. Then next, okay, so the perimeter of this one, right? So if you want to, what's the perimeter of this building? So for this one, we can always do this. Okay, we can always map something to a rectangle. Okay, let's use another color to show you. Okay, so we have this one, right? This one we can map to here, and this one getting mapped to here, right? And this one getting mapped to here, and this one getting mapped to here, right? So all these 4 pieces become this. Now let's change another color. So this piece get mapped to here, right? And this piece up to here, right? Getting mapped to here. So these 2 pieces getting mapped to this. So basically all the colored piece getting to map to the to a rectangle. So that's why the perimeter is equal to 2 times 11 plus 7. That's the rectangle, right? But there are 2 pieces not mapping. One is here and one is here. So 2, that's 4 is 18. 36 plus 4 is 40. Next. Okay, so the cx equals 2bx. Let's do the let's mark here 2a and a, and ay is 3by. Let's see, it's 3c and c. Then find the bxy. Bxy is here. That is the given that ABC is 144. Okay, so you can see ABC is 144, right? So this triangle this triangle, okay? So triangle AXB is because it's same height, right? So it's the 1/3 of the triangle ABC. right? Now let's see the other one. Is this one, right? So the triangle BXY is just the 1/4 of the triangle AXB. Right, here is the XB, here is the XB, so you can see BXY is equal to the 1/12 of the triangle ABC is equal to the 144, and 12 is equal to 12. Next. So for this one, so I mean, we're placing the 4 square 1, 2, 3, 4 together, and each square has a side length that is half of the side length of the next large one. Okay, so now let's see, the smallest is A. Oh, the smallest is A, then it's 2A, it's 4A, and it's 8A, right? Like what we talked before, so we can do this, right? So we can map this one to here, this one to here, this one to here, and map this one to here, here, here. So now you can see, okay, the outer perimeter, the perimeter basically is a rectangle, right? Is 2 times the 8A plus the A plus 2A, 4A, and 8A, right? So that's the 16, yeah, 16 minus A, that's the 15A. Okay, so this one is the 46A is equal to 115. So now you can calculate the A is equal to 115 over 46 and the 23, so it's 2 over 5. 5 over 2, right? That's A. So now we need to calculating the area, right? The area is A square plus the 4A square plus the 16A square plus the 64A square is equal to the A square, right? So it's 1 plus 4, and this one together is 80, so it's 85, right? So now the S is S this shape, then the S is equal to the 4 over 25 over 4 times 85. So this one, let's say the Susan and Barry are trying to find the area of triangle ABC, and the Susie used the AB. So Susie used the AB, that's the side length C, and the height from the A, this length, right? The Susie calculated in this one mistakenly. It's supposed to use HC, right? And the Barry mistakenly used the C, use the BC, that's A, times the height from the C, okay? Supposed to use HA, right? So if Susie find, let's see the A. Okay, if half of the C times HA is equal to 12, and the half of the A times HC is equals to 27. So what is the triangle area ABC? Okay, the area ABC is supposed to be C times HC, A times HA. Then it gives you a strong hint, right? So basically, if we times them together, we have the 120C times HA times the half of the A times HC. Then we regroup it. This one and this one. So this one is triangle ABC, this is triangle ABC, so we get the ABC square is equal to 27 times 12. Then the S triangle ABC is equal to the 3 times 4 times 3 is 3, so it's 9 times 2 is 18. Okay, so the second question is very similar. So it tells you that Susie find is 120 and the Berry find is 150, right? So that's why the B is just the same thing. ABC is equal to square root of the 120 times the 150 is equal to the 10, take it out, and the 3 times 4 times 3 times 5. So it's the 6, so 60 square root of 5. Next. Okay, so we have the I want to rectangle here, right? I want to show you the area of the WPX. WPX is this one is equal to WPZ. So 1 and 2. The goal is to try to prove the S of the 1 equal to the S of the 2, right? So how we prove it? Now let's do length some height. Okay, I call it XA and ZB. Okay, length and height. So for the rectangle, right? And the WY is the diagonal. It's cutting the rectangle into into 2 equal pieces, right? So means the triangle WXY is equal to the triangle ZWY is equal to half of the rectangle of the XYZW. Then if you know this, now you can see, so the triangle WZY is the WY times the height, right? I call the H1, and the triangle WXY is the WY times the AX, right? So that's why you can have H1 equals H2. Okay, the height is the same. If H1 equals H2, then let's see. So the triangle of the WZP is equal to half of the WP times H1. The triangle WXP is equal to half of the WP times H2. So H1 equals H2, WP equals WP, so they are equal. So this one, we have the coordinates, right? So we have the A is coordinates 0, 0, and the B coordinates 2, 0. If you are not familiar with, go to the algebra. Go to Intro to Algebra, Chapter 8. Okay. Then we try to, there is a center is 3, 2, and we have a circle here. Okay, we try to find some point on this circle. Okay, we try to find some point on this circle. Okay, to maximize the triangle ABC. For example, this is the C, right? Let's see what's the key point here. So in order to calculate the triangle ABC, so we have the base is AB, which is the fixed length, right? It's fixed. Then we times the height. We want to land C to a height, right? So with a fixed length, to maximize this, we want to maximize the height. Okay, so now you really understand it's where is the on this circle where the C have the largest height against the x-axis. Of course, it is here. It's the diameter here. Okay, this is the highest point on the y. So that's why you can see this is the 3, right? And the radius is 1, so this is a 4. So the height is 4. Okay, now you solved it. So the max of triangle ABC, half of the 2 times 4 is 4. So this one is the, if I have this one is it's in geometry there is a famous theorem called the Chiva Theorem. Okay, so I have a triangle ABC and I have 3 lines from the A to the sides of the BC, B to the sides of the AC, and C to the sides of the AB. I have 3 lines and intersect at one point. Okay, here is the Chiva theorem. It's to prove the concurrent. Means I have 3 lines, they pass in the same point, is the concurrent. Now let's prove this. So we want to prove the AXC. We want to prove the AXC. Okay, and the BXC. We want to prove the AXC and the BXC. Okay, is equal to the area is equal to the AF and the BF, right? Let's extend in this one. So let's length the height and let's length the height. Okay, so if we length the height, right? So you can see, I mean the area of the ACX is half of the CX times H1, and this is H2, right? Times H1, and the S of the BCX is equal to half of the CX times H2, right? So you can see the SAXC over SBXC is equal to H1 over H2. The H1 over H2, right? So this is the right angle, and we also have, this is not a good picture. Let me intentionally draw not very perpendicular. Okay, let's do this. A, B, C. Okay, so we have the H1 here and the H2 here, right? And you can see we have this angle equals this angle, right? So what I want to see is this triangle is similar to this triangle. Okay, so that's why this one over this is equal H1 over H2 is also equal the hypotenuse AF over CF. B, I'm sorry. This is the B, this is the C. Okay. Next. So in the diagram, we can see it gives you the relationship of the PQRS, and the PQA, and PQRS and the PSB, right? We want to find the ABP, ABP, and the PQRS. So now let's see it. Let's do this one is the A and this one is the B, right? So the PQRS is equal to AB is equal to 5 times half of the PQA is the QA times the B, right? So now we can solve the QA is 2 over 5 of the A. So this is the 2 over 5 of the A. So now this is 3 over 5 of the A. Okay, now similarly we can do PQRS is equal to AB, now is equal to the 4 times the PBS, right, is half of the SB times the A. Then we can see SB is half of the B. It's B over 2, B over 2. Okay, since you solve this, right, in order to solve this, it's not easy, but we can use this 1, 2, 3. Okay, we can use the rectangle to take out the 3, right? So the APB is equal to the rectangle AB. Take out the 1 and the 2 and the 3. Then is equal to the AB minus half of the A times B over 2 minus half of the B over 2 times through 5A minus half of the B times the 2 over 5A. Then is equal to the AB. Then 1 minus 1/4 minus the 3 over 20 minus the 1 over the 5th is equal to the AB. Let's do the common denominator is 20 minus 5 minus 4 minus 3. That is equal to the 9/12 is is 8. 8 is divided by 4 is 2 over 5 of the AB. So now you can see the AB PQRS, right? So now you can see it's the answer will be this. Next. So on the right we have a rectangle. We know the CBP, the CBE. Let's see this is the 1. ADE is the 2, and the AEB is the 3. So we know 3 minus the 2 equals the 2 minus the 1, right? What's the ratio of the area of the largest to the smallest region? Okay, so 1. So because the 3, right? The 3 is half of the ABCD, right? So let's assume ABCD, because we can't do about ratio, right? So let's say it's 1, so it's 1/2. Then we can see the half minus the 2 is equal to 2 minus the 1. So we can have the half is equal to the 2 of the 2 minus the 1, right? And the 3 is half, so also we have another one is 2 plus 1 is also half. Okay, so by doing this, we add them up, okay? So we know that 2 is 1/3. Then if we do 2 is 1/3, 1 is 1/6, then the 3 is 1/2. So the max over min, okay, is 1/2 and 1/6 is 3. So final one is the we bought a 7 by 7 inches of the square birthday at the flat top. If it is the chocolate cake with the banana frosting on the top and on the sides, it turns out 7 people will be present when the cake is cut, and each person will become quite envious if another person received more cakes of frosting. So find a way to divide the cake among 7 people. Okay, so we have the frosting here and on the top, right? So, and they want to get the same cake and the same of the frosting. That means that we need to cut in the square into 7 equal pieces, equal area piece. Okay. Okay, so how to cut this one into square into 7 equal area piece? Okay, I give you some hint. I mean, if we have a circle, right? Then if the cake is circle, then we can cut this one as half, right? It's a diameter, and we can use the two perpendicular diameter to cut into the fourth, right? So now we can cut it into the equal piece here, right? But this is the rectangle, this is the square, right? So square still have a center. Okay, so how we can calculate the area, right? So the area will be the size times the height, right? So you can see if I put one point here and I put another point here, then the area is the half of the size times the height, right? So all the height, if I put to the center, all the height are the same. Okay, so this is the h0, this is h0, this is h0, and this is h0. So the rest of them I want to cut in is a times h0 is equal to the 7 times 7 divided by 7, so each piece will be 7, right? So how to make this one equal? Because h0 is constant, is the 7 over half. So we want the a is equally splitted, right? So that means each a is equal to the 4 times 7 divided by 7. So each a is 4. Okay, so we want to cutting the sides into the equal piece of the 4. Okay, now let's starting anywhere. Okay, how about we starting here? We do this and we cutting as 4. So this is the 4. Okay, then this is the 3, right? So the 3 means we have this piece of 3, but we need 4, right? So but if we can convert into here, so we can have a base of the 3 plus base of this one, and because the height is the same, right? So we can do this. So this is the second piece. Okay, so this is the first piece, this is the second piece. Then the third one, right? Because we already have 1 here, we have 3 here. Then the third one we want to keep as 4. Then 1 plus 4 is 5, right? So here is another 2. Then, but if we have 2, we still want a 4, right? So we can have another 2. So this is a 1 and 2 and 3 and 4. Then we can have another 4, right? And 5. So that's 6. So this I have 1 here, right? If I have 1 here and I need 3 here, 3, that's 6, right? If I have 3 here, I finally have 4 here. So you can see by cutting in this way, okay, you can have all of the 7 pieces. Okay, they have the equal sum of the sides are equal, and they can cut in the area into the 7 equal pieces. So that's it for this chapter. Thank you.